everyone, I am Shravani Kare from MIT AOE and today I will be explaining VERILOG to you. So, what is VERILOG? VERILOG is a hardware description language that is used to model and simulate digital circuits. It allows designers to describe the behavior and structure of electronic systems using code. The basic concepts of VERILOG include modules, ports, registers and wires, and procedural blocks. Modules in VERILOG are like the entities in VHDL. The primary building block is a module, which represents a hardware component. A module can include input, outputs, and internal logic. Ports. These are the inputs and outputs of a module, through which it communicates with other modules. Ports can be of different types, such as input, output, and in-out. Verilog uses different data types to represent signals, that is, wire and registers. In VHDL, we can simply use the signal assignment, but in Verilog, we have two types, wires and registers. Wires represent a continuous signal used for connecting different parts of the circuit, and registers store a value until it is changed. It can be useful for flip-flops. In procedural blocks, there is always blocks and initial blocks. Always blocks is used to describe the behavior of circuits that change in response to signal. For instance, they can model clocked operation or combinational logic. Initial blocks are used for initialization mainly in test benches rather than actual hardware synthesis. Now let's take a look at why we should even use this language. So there are three main points: simulation and verification, synthesis to hardware, and concurrent execution. Verilog lets designers simulate how digital circuits behave, which allows them to catch design errors early. The code written in Verilog can be synthesized to produce actual hardware on FPGA or ASIC. And unlike traditional programming languages which execute instructions sequentially, Verilog allows for a concurrent execution, which is essential for modeling the parallel natures of hardware. Now let's look at the comparison of Verilog and VHDL. So the language type of Verilog is hardware description language, which is similar to C. The syntax of Verilog is also very C-like. However, VHDL is similar to ADA and Pascal. It is more verbose and it has a structured syntax. Verilog is very case-sensitive language, which means that even a capital letter can cause errors if not monitored properly. However, VHDL is not case-sensitive at all. Verilog uses modules to define a design, and VHDL uses entity and architecture to define a design. Port declaration in Verilog is separate lines for input and output declaration. However, in VHDL we can group the inputs and outputs together in a port block. Verilog has very few built-in data types: register, wire, and integer. And VHDL has a rich set of data types like STD logic, bit, integer, etc. Verilog uses squares for vector declaration, and VHDL uses the down to logic. The learning curve can be easier for Verilog if you are already familiar with C programming, and VHDL has a steeper learning curve as it has a more formal structure.
Now I'll explain the 8:1 MUX in Verilog code. I'll first start by creating a new project and naming it. Then I will add a new module. I will name that as well. I need three components for this code, which is A, S, and Y. So I will declare A and S as inputs and Y as output. Then I will select the size of A from 7 to 0 and the size of S from 2 to 0.
So as you might have noticed, we call this module declaration, but in VHDL this is where we would declare our entity and start the code.
So the line always at the rate bracket star bracket close tells Verilog to execute this block of code whenever any of the inputs change. So it's like saying if anything changes, update the output. Inside this block, we use a case statement which works like a menu of option. It looks at the value of the selection input yes and decides which input from A0 to A7 should be assigned to the output Y.
So I'll just keep the output equations of the 8:1 MUX here, and so you can compare it with the code.
3 tick B000 is assigned to Y is equal to A of 0. So this means if S is 3000, which means 0 in binary, then Y will be equal to the 0th value of A, which is the least significant bit of A. So I will repeat this 7 more times until A7, which is the most significant bit of A. So it will mean that the 7 in binary will be assigned to A7. The line default y is equal to 1 tick b0 is a safety measure. It sets the output y to 0 if the selection input doesn't match any of the expected values.
Now I am going to add the end case and end statements, and then I will check the syntax.
So as you can see, I forgot to declare y as a reg output. So here you can see we can edit the module within the code itself as well. I fixed the error by adding reg to y. So let's see if the code works now. As you can see, the syntax check was successful. So now we will generate the RTL schematic. So after this, we will create the test bench waveform. So I created a new source, and under the Verilog text fixture, I named it as well. Then I added the code for the text test bench. Then I added the code statements for the test bench to test it.
Then I will simulate the code, and as you can see, we have successfully created the test bench waveforms. That is it. Thank you for watching. I hope this was helpful.